is straight line?
Equation of a
Yes.
line is
Y equals mx plus c.
Yeah. Y equals mx plus c. And what is m and what is c? What does m refer to and what does c refer to?
M is the gradient.
Yes. M is the gradient and c is the
Um, C is the shoot, I forgot what I want to know. Hmm.
anybody.
dy.
Anybody. What is c in the
dy
equation of
intercept
a line? Yes. The y-intercept. What is that fired? What is the y-intercept?
is where a line passes through the y-axis.
Excellent. So the y-intercept is the point at which the line or the line, the graph cuts the y-axis. All right. What else, boy? Okay, so that's the equation of a line. What about the formula to find the gradient of a line? Um, who can recall? What is
M
the gradient?
equals
Uh-huh,
y2 minus y1 divided
uh-huh.
by x2 minus x1.
That's right. So m equals y2 minus y1, oops, over x2 minus x1, where that x2, y2 is the coordinates of one point, and x1, y point is the coordinates of another point, all right, on the same line. Um, different types of lines have different types of gradients. What kind of gradients would I expect from a line that increases from left to right like this?
Positive.
That's right. So this would be so it's only Zach that remember anything.
I just go
So
like that.
this
Don't worry about
this is a positive gradient. What about a line that is decreasing from left to right?
that. Negative gradient.
It has a negative gradient, right? What about a horizontal line? What kind of gradient does a horizontal line have?
0.
Yes, the gradient m is equal to 0. And of course, a vertical line, the gradient is
Undefined.
undefined. Perfect. All right. So these are some of the things that we learned. So it means that if you are solving a question and the line looks like this, and somehow when you work out the gradients, you get a negative gradient, you're wrong because you're supposed to know that when a line is increasing from left to right like this, you should get a positive gradient. And that's why it's important to know these little things. So while you're doing your questions, it will be able, it can guide you. Something else about the gradients. Perpendicular lines, what about them and their gradients?
Are they equal to each other? What are you saying?
Parallel lines have equal gradients, Zach.
Oh,
Perpendicular lines, there's something else. Anybody recalls what it is? What's the relationship?
Product of the product
Miss
of the
Anita.
gradients is one.
Yes, the product of their gradients is -1, right? So the gradients of perpendicular lines, the product of it is -1. So that would mean, hold on. Yeah, that would mean like if you have a line and let's move on to another page here. Like let's say you have this line and then a line perpendicular to it. Let's say this line, the gradient is m is equal to 2 over 3. Then the gradient of, so this line is, let's say this line is A, right? This line is AB, and then this line is CD. If the gradient of AB is 2, 3, then the gradient of CD would be -3 over 2. So the product of the gradient of perpendicular lines is -1. You can recall it as that, or you can think of it as they have negative reciprocal gradients, right? So if the gradient of one line is 2 over 3, then the gradient of a line perpendicular to that would be -3 over 2. And when you multiply that, which is what the product means, you'll end up getting -1, right? And then, well, Zach told us that the gradient of parallel lines, they have equal gradients, right? So parallel lines have equal gradients, right? So far, we know that the equation of a line of any straight line is y is equal to mx plus c, where m gives us the gradient and c gives us the y-intercept, which is where the graph cuts the y-axis. The formula to find the gradient when you have 2 points on a line would be y2 minus y1 divided by x2 minus x1, where those are 2 points on the line. Y2 and x2 are the coordinates of one point, and x1 and y1 are the coordinates of another point. Any line that is increasing from left to right like this, it's a positive gradient. If the line is decreasing from left to right, it's a negative gradient. A horizontal line has a gradient of 0, and a vertical line has an undefined gradient. The product of gradients of perpendicular lines is -1, or we say that they have negative reciprocal gradients, right? Meaning that if the gradient of one line is, let's say, 2/3, the gradient of a line that is perpendicular to that would be -3/2. And parallel lines have equal gradients. I think last week, did I teach you all the length of a line and finding the midpoint of a line as well? Guys, did we go through that last week? The length
Yes.
of a line? Okay. Right. So the formula, Fire, tell me, what's the formula for the length of a line?
The square root
Mm-hmm.
of x1 minus x2 squared plus y1 plus y2 squared.
Right. So the square root of x1 minus x2 all to be squared plus y1 minus y2 all to be squared. It is derived from Pythagoras' theorem. What about the midpoint of a line, guys? Did I give you that one, Fire? No? I didn't give you all
Yeah.
the formula for midpoint. What is it?
For the midpoint of a line, it is x1 plus x2 divided by 2 and y1 plus y2 divided by 2.
That's right. All right, where x1 and y1 are the coordinates of one point, and x2 and y2 are the coordinates of the second point, being the endpoints of the line, by the way, right? So for the midpoint of a line, these would be the endpoints. For the length of a line, similarly, it would be the endpoints that you're using. Meaning that if you have a line AB like this, right? Then this would be x1, y1, and then this would be x2, y2, right? So it has to be the endpoints of the line. Cool. So that's basically like kind of like a rundown on all the things you need to know about coordinate geometry, right? Before we could do some questions. Oh, finally, actually, to determine the equation of a line, all you need is a point on the line and the gradient, and you substitute that into y is equal to mx plus c. So we're gonna start right away with our the participle questions, right? I think last week, did we do one of them? Did we do this one? January 2009. I know I did a question with you last week, but I can't remember which one it was. Let me see. Zach, you left early last week, correct?
Yes, miss.
Okay, so then you may have missed this
Yeah, I
stuff.
missed a good bit of stuff, yeah.
Okay. All right. Well, we did this question already. So we're gonna just do another question. So we're gonna start with January 2010. All right, guys. It says a straight line passes through the point T, which is 4, 1, and has a gradient of 3/5. Determine the equation of the line. So to determine the equation of a line, guys, literally all you need is a point on the line. So here we have a point. It's 4, 1, and you need the gradient, right? So once you have a point and the gradient, you could determine the equation of the line by substituting that point and that gradient into the equation of a line. So to solve this question, and it's 3 marks, 3 easy marks, you substitute the point for 1 and m is equal to 3/5 into y is equal to mx plus c. to find what C is. All right. So basically, what you're substituting, well, in the point, 4 is your x coordinate and 1 is your y coordinate. So wherever you have x in the equation of the line, you will replace it with 4. And wherever you have y in the equation of the line, you will replace it with 1. So this would end up being 1 is equal to m, which is the gradient, 3/5, times the x coordinates here, which is 4, plus c, right? And then you work that out. You could literally work it out on your calculator, or you could work it out manually. Well, this would be 1 is equal to 3/5 times 4, which is 12/5 plus c. And if 1 is equal to 12/5 plus c, then c would be equal to 1 take away 12/5. 1 take away 12/5, which is negative 1 2/5 or negative 7/5. All right, so now that you have C, you have M, you rewrite the equation of the line, replacing M and C. So therefore, the equation of this line would be, y is equal to 3/5 by x minus 7/5. And these are the exact steps that you use every single time to find the equation of a line if you have a point on the line and the gradient. You can also do the second method, which I think you were doing, Aaron. The y minus y1 is equal to x by m by x minus x1. You remember that one, Aaron? I think you had preferred that one. Is Aaron here? I don't know if Aaron is here, but let me just show you all that method too. That would be, you have y minus y1 is equal to m by x minus x1. So you're going to be replacing y1, x1, and m, and you're just going to end up with the full equation. You don't have to rewrite it or anything. So to work it this way, you would say y take away y1, which is 1 in this case, is equal to m, which is 3/5 by x minus x1, which is 4/5. Not 4/5, sorry, just 4. Sorry, x is 4. Right? And then you work this out to simplify it. You simplify it and you make y the subject. So this would be y is equal to 3/5 times x, which is 3/5 x. 3/5 times negative 4 would be negative 12/5. And since you're moving minus 1 to the other side, it will become plus 1. And I'm going to write that as a fraction. 1 whole would be 5/5. So finally, you would have y is equal to 3/5 x minus 12 plus 5 is minus 7/5. So as you can see, you're still going to get the same answer. One method, you substitute the values in to find out what C is, and then you rewrite the equation, replacing M and C. Or the second method, you substitute into the equation y minus y1 is equal to m times x minus x1, and then you simplify and make y the subjects of the formula. Both methods, you're going to get the same answer. All right, so let's look at this other one. Don't worry, guys, if you didn't get through it writing this out fully as yet. I am going to send this afterwards, and I am going to post the recording so you can watch it over, pause it, make your notes, however, right? Oh, this year, January 2011, was actually the year I wrote exams. Huh. The equation of a straight line is given by 3y is equal to 2x minus 6. Determine the gradient of the line. Now, remember, you can determine the gradient of a line by simply looking at the equation. However, the equation has to be in the form y is equal to mx plus c. The coefficient of y has to be 1. So for this question, you wouldn't just say that the gradient of the line is 2. That would not be correct because this equation is not fully in the form y is equal to mx plus c. You need it to be in the form y is equal to mx plus c. So to get this equation in the form y is equal to mx plus c, I would divide throughout by 3. Dividing throughout by 3 will give me y, because 3y divided by 3 would be y. 2x divided by 3, well, that would be 2 over 3x. And then 6 divided by 3 is 2. So the equation of the line would be y is equal, in the form y is equal to mx plus c, would be y is equal to 2/3 x minus 2, where here m, the gradient, is 2/3. So the gradient of this line is 2 over 3. That's the gradient. Okay. The next part of the question, the equation of the line which is perpendicular, we have to determine, the equation of the line which is perpendicular to 3y is equal to 2x minus 6 and passes through the point 4, 7. So a useful piece of information here, and I think part of the key piece of information here is that it says this line that we're trying to determine the equation is perpendicular to this one, right? What do you guys know about the gradient of perpendicular lines? Fire, tell us. What do you know about the gradients of perpendicular lines?
The product of it is -1.
The product is -1. So that means if this line is perpendicular to this one here, whose gradient is 2/3, what would be the gradient of this perpendicular line? Fine, for you again. Fire, are you still there? Did we lose you?
No,
So what would be the gradient of this perpendicular line? This line is
negative,
perpendicular. I didn't hear you. What would it be?
-2.
No, the gradient of the first line is 2/3. So the gradient of a line that's
Ah,
perpendicular to that would be what?
-2/3.
-3/2,
Ah,
because
2.
it's going to be the negative reciprocal of that gradient. I think that's actually the same example I gave you all just now, right? So guys, if you know the gradient of a line, you can find out the gradient of a line that's perpendicular to it by simply flipping it, literally inverting it, taking the reciprocal and making it negative. So since the gradient of the first line, 3y equal 2x minus 6 is 2 over 3, then the gradient of a line that's perpendicular to that would be -3 over 2. All right. And now you have a point on the line. So you have the point 4, 7, and you have the gradient. So you can substitute that point and the gradient into the equation y is equal to mx plus c to get the equation of this perpendicular line. All right, so we're going to sub 4, 7, right? That's the point on the line, and the gradient m is equal to -3 over 2 into y is equal to mx plus c to find what c is. All right, so to do that, y would be 7 and x would be 4. So wherever I have y in the equation, y is equal to mx plus c, I'm going to replace that with 7. So it will be 7 is equal to m, which is -3 over 2. times x, which in this case is 4, right? Plus c. And then I simplify this. So this would be 7 is equal to, well, negative 3 over 2 times 4 is negative 6. So 7 equals negative 6 plus c. And if 7 is equal to negative 6 plus c, then 7 plus 6 would be equal to c, making c equal 13. Now that I know what C is, I can rewrite the equation of the line, replacing M and C. So the equation of this perpendicular line would be equal, or will be given by y is equal to M, which is negative 3 over 2, x plus 13. There you have it, right? And guys, let me show you all how this would look on a graph, right? I want to show you guys. So let me just, you can use this website called Desmos. I don't know if you all know about Desmos, but it's an online graphing calculator. And it shows you the graphs. Like you could enter the equation of a line and you could see how the graph looks. You could enter the quadratic, anything, right? So the first one is, let's just go back here. It was 3x is 3y is equal to 2x minus 6. Let me type it in and stop being lazy. Yeah, that was 2x minus 3y, oops, 3y equals 2x plus 6, right? So this is the graph of the original equation here. 3y is equal to 2x minus, oh, it's minus 6, sorry. I put plus 6. That should have been minus, yeah. And then the other one, the equation of the line that we just found is negative 3 over 2, which is negative 1.5. So negative 1.5 x plus 13. So let's draw that. Y is equal to negative 1.5 x plus 13. And there we have it. So you can see that this graph, each of those lines are perpendicular to it, meaning that perpendicular means that it forms a right angle. Here it is, right? A right angle. Now you would expect the red one is the original equation, right? And that is the gradient was 2 over 3, all right, which is a positive gradient. And as you see, that line is increasing from left to right. And then, therefore, the gradient of the perpendicular line, which is negative 1.5, is negative. So it's decreasing from left to right. So this is how the two graphs would look. Another thing is the equation of the line. Well, remember, we had to rewrite the 3y is equal to 2 x minus 6 in the form y is equal to mx plus c. Let me show you that it doesn't matter if you write it in the graphing calculator. It wouldn't matter if you type in the equation in the form y is equal to mx plus c, or in the given form, you would still get the correct equation. So if I were to write it in the form y is equal to mx plus c, which is what we had to do to determine the gradient, it would be y is equal to 2 over 3x minus 6. Minus 2. So you see, it's the green line and it is now overlapping the first one. So it's literally the same line, right? So it doesn't really matter. Once you simplify it correctly, you'll get the correct equation. So from the equation, y is equal to 2/3 x minus 2, c, which is minus 2, is the y-intercept. That is where the graph cuts the y-axis, right? And as you can see, the graph cuts the y-axis at negative 2. So the equation of this graph is y is equal to 2 over 3x minus 2, where minus 2 is the y-intercept. All right. And then the other graph, which is this one, the blue one, the line that's perpendicular. All right. As you can see, this cuts the y-axis at 13. And the equation of that graph is y is equal to negative 3 over 2, which is negative 1.5x plus 13. And this point here is plus 13. That's C, the y-intercept. Okay, so I just wanted to show you all that to just put it into context. All right, let's go back to the questions. So this is 5 marks, guys. I think 5 easy marks. All right. Actually,
5 easy marks.
Yeah, 5 easy marks. What do you think? You don't find it was 5 easy marks, Aaron?
Yeah, miss. For you to say.
It's 5
That
easy
easy for you
marks,
to
bro.
say.
But Aaron, use me guiding these things. Use me guiding these things like nothing.
Yes. I'll be in that kind of mood. You see why in that kind of mood now to do maths. When I'm in school, I will be in a mood to do maths.
That's all right. Once you're in the mood for the exam, I don't care what mood you're in anytime other than that.
I hope so.
You will be. You will be. Don't worry. So this actual question was on my paper when I wrote CXE. That makes me feel so very old. That is how many years ago? 14 years ago. What the jail? All right, guys. So the diagram below shows the line segment which passes through the points A and B. The first question, which is with 2 marks, is to determine the coordinates of A and B. All right. So remember, guys, when you are determining the coordinates of a point, you always read the x-axis first, right? So you have to check what is the point on the x-axis first. So the point B is 4. And then the y coordinates of B is 6. So the coordinates of B would be B is 4, 6. Okay, my 4 kind of looking like a 9, so let me fix that. Yeah, 4, 6. All right. And then for your A, for the coordinates A, that would be, again, you read your x coordinate first, so that's negative 2, 3. All right, so always horizontal and then, always vertical and then horizontal. Always read the x and then the y. So the coordinates of A would be, oops, sorry. I should actually be using I'm using the wrong thing here, right? So the coordinates of A would be negative 2, 3. And then the coordinates of B is, 4, 6. All right. That's 2 marks, guys. Aaron, what you think? 2 easy marks or no? To determine the coordinates of A and B. Easy or no?
Um,
Come on, you know that was
yeah.
easy. You know that was easy. I feel people would just
My
be scared to say
brain,
something.
I'm sick right now, you know, so that's why my brain right now.
Oh, your brain not braining. All right, I get it. Evan, was that okay? 2 easy marks. What do you think?
Yeah, miss, that's 3 marks.
Yeah, exactly. Free marks, free money, guys. Good. So the next part is to determine the gradient of the line segments AB. I want all of y'all to try it for me, right? To determine the gradient of the line segment, remember the formula is, oops, why did I write y? The gradient M is y2 minus y1 divided by x2 minus x1. Y'all try it out for me. Your y2 are your y2 and y1 are your y coordinates, and your x2 and x1 are your x coordinates. So literally just substitute the values in there. Determine which ones you're using first, whether you're using A. If you're using A, that would be, you'll start with 3 as the y coordinates. And then it means that on the bottom, you have to start with the corresponding x coordinate. So it will be negative 2. All right, so try that one for me, guys. I'm giving you 1 minute. M is equal to y2 minus y1 over x2 minus x1. And Zach, are you there?
Yeah, miss.
You'll give us the answer.
Huh. Huh. Right. I don't get that, miss.
Take your time.
We're using was on the screen, right?
Yeah. The
Right.
coordinates A and B, and then you're using the formula to find the gradients.
All right. Give me like the half.
Take your time. If anybody else figures it out before, send it to me in the chat on Zoom, not WhatsApp.
That I think um
Tell me what you wrote first, honey, before you tell me the answer. So M would be equal to what?
M would be equal to 6 minus 3.
Mm-hmm.
Divided by, well, over 4 minus 2.
Yes. But Zach, it will be 4 minus negative 2.
Oh yes, because it's a
Yeah?
negative.
Correct.
Mm-hmm.
So I want you to be very careful with that, right? So Zach used x1, well, y2 as 6, so then x2 would be 4. And then x1 was negative 2 and y1 was 3. So it was 6 minus 3, the difference of the y coordinates, divided by the difference of the x coordinates. You were correct in saying divided by it. That's what over means. So for takeaway negative 2, that part, guys, this part here is a part that is a little tricky. Sometimes students make a mistake with this part here. So I want you all to be careful with that. If you're subtracting a negative number, that's the same as adding. So M would be equal to 6 minus 3, which is 3, and then 4 plus 2, which will be 6. So the final answer, the gradient, is 1/2. Anybody got that? 1/2?
Yeah, miss.
Nope.
No?
When I did the correction, I got it.
Yeah, miss, but I do
Good.
it the other way.
Okay, so you did 3 takeaway 6.
Yeah, miss.
All right. So yeah, you could have done that too, right? Because it doesn't matter which ones you use as Y2 and Y1. So you could have done 3 takeaway 6 instead on top, and then negative 2 takeaway 4.
I see where I'm going wrong now.
Okay, good. And 3 takeaway 6 will be negative 3, and negative 2 takeaway 4 is negative 6, which will be positive 1/2 because a negative divided by a negative is a positive. All right, good. I'm glad you saw your error, Aaron. So the first question, the answer for that first
MS.
part was, well, the coordinates of A and B, and then the gradient of the line segment would be M is equal to 1/2. All right, the coordinates of A were negative 2, 3, and then the coordinates of B were, what was the coordinates of B again? 4, 6. All right, good. So now the final part of the question for 2 marks is to determine the equation of the line which passes through AB. So guys, to determine the equation of the line, you simply take one of those points and the gradient, and you can either substitute it into y is equal to mx plus c, or you can substitute it into y minus y1 is equal to m times x minus x1, right? That is how you will determine the equation of the line. So I'm going to use both methods, and you could do it as well while I do it, or you could follow along, right? So to determine the equation of a line, you will substitute a point on the line. I'm going to use B because I just want to use positive numbers, right? So substitute 4, 6, and m is equal to a half into y is equal to mx plus c. We're doing this so that we could figure out what c is to be able to rewrite the equation of the line. All right, so here y would be 6. 6 is equal to m, which is a half, times x, which is 4, plus c. So this will give me 6 is equal to, well, a half of 4 is 2 plus c. So therefore, c is equal to 6 take away 2. So c is equal to 4. And therefore, the equation of the line would be y is equal to a half x plus 4. All right, that's one method. The next method is to do that same thing, substituting 4, 6, and m is equal to a half into, let me use a different color, into y minus y1 is equal to m by x minus x1. And all you're replacing here, you're going to be replacing y1, x1, and m. Everything else remains the same. So this will be y minus y1 would be the y coordinate that you're using. So y minus 6 is equal to m, which is a half, by x minus the x coordinates, which is in this case 4. All right, and then we work that out. So y minus 6 is equal to a half x, and then a half times 4 is minus 2, and then you have to make y the subject, so you're going to move minus 6 to the other side of the equation, which would make it plus 6. So you'll have y is equal to a half x minus 2 plus 6, and that gives me a half x minus 2 plus 6 is 4. So both methods, you're going to get the same answer, which is y is equal to a half x plus 4. And there you have it, guys. 2 more marks, a 6-mark question in the bag. Y is equal to a half x plus 4. I hope you all realized, all right? This is like, so this is 1, 2, 3, and we did this one last week. So 4 years of past paper questions. And as you can see, well, based on the coordinate geometry topic, and you're basically seeing it's the same kinds of questions they're asking you all the time, right? That should give you an idea of what you need to know. You need to be able to determine the equation of a line given a point and the gradients. You need to be able to use the factor of the gradients of perpendicular lines being negative reciprocals of each other to determine the equation of a line. All right. So you need to be able to correctly identify points on a line. It's the same thing, guys. It's always the same thing that is being tested. And your job as you prepare for exams is to really get familiar with what they ask you to do, because the only things that will change is the numbers, but the steps and the strategy remains the same. And this is so not only for your math exam, but for all of your exams, all right? Nothing new comes. It's always the same thing. All right, everybody with me? Zaydan, you there? Follow it? Not hearing you anymore.
Of course, miss, of course.
Okay. All right, Maya. Maya, how we
Yeah,
going?
miss, sorry, sir.
Yeah. All right, all right. Jazara, how you going there, honey? All right. Christian, you could hear me? I don't know if Christian could hear me, but oh, I didn't even tell you that we have another new student in class today, Christian. This is actually my brother. All right.
Yeah, miss, because I see the Garcia and I was out and I was contemplating.
Yes, it is. It is my brother. Right. So June 2012, let's look at this question. Oh, guys, I want you all to try this one for me, please. the midpoint of the line segment, TS, and the length of the line segment, TS, you have to use the midpoint formula and the length formula for those two. But try it out now. Try out this question, June 2012. I'm gonna pause the recording while you'll try it, and then I'll go through it completely with y'all. Right. So the gradient is equal to y2 minus y1 over x2 minus x1. So if I'm using the point T as my x2, y2 points, the y coordinate there is -2. Take away the y coordinate of S, which is 6, divided by the x coordinates of T, which is 0. Take away the x coordinates of S, which is also 6. So this will give me -2 take away 6 is -8 over 0 take away 6 is -6. And then, well, this is going to be positive because a negative divided by a negative is a positive. And you can reduce this. 2 into 8 is 4, and 2 into 6 is 3. So the gradient is 4/3. Anybody got 4/3 as a gradient?
Miss,
Hmm?
how I get 2?
How did you get 2? I don't know. I don't know. What you had as the y2 minus y1?
Miss, I had Miss, 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 I put x1 6, x2 6, y1 0, y2 2.
Oh, that's what you did. So you're really supposed to have x1, y1, x2, y2, right? Evan, did you get 4/3 as your gradient?
No, miss, I do it wrong.
Okay, where did you make the mistake?
I put 6 6 -2 -0.
Oh, okay. Okay. So same thing. They done made the same mistake, right? So if you could have either said -2 take away 6 divided by 0 take away 6, or you could have done 6 take away -2 over 6 take away 0. And that would have given you 6 take away -2 would be 6 plus 2, which is 8, and 6 take away 0 is 6. So either way, you would still get 4/3. Josara, did you get it, love? The 4/3 as the gradient?
Yes, miss.
Okay, cool. So now to determine the equation. Oh, wait, Zach, my boy. Were you able to get the gradient, love?
Miss Zach now, yeah.
Where did Zach go? I wonder if Zach ran away.
Miss, he going to the bathroom.
Okay. All
Oh, you
right.
know that.
Hey, then, hush.
Zach is my neighbor, way.
So you can see if he goes to the
You
bathroom
can see from your house to his house in the toilet.
Don't study that way.
All right. So for the equation of the line, you would substitute, guys, the gradient, which you just found, as 4/3, and one of the points into the equation y is equal to mx plus c to find c, right? Zeta, that's how you find c. So you substitute one of the points, any one of the points. So I'm going to substitute 0 and -2 into y is equal to mx plus c to find c. All right, so that would be, well, wherever I have y, I'll replace it with -2. So that'll be -2 is equal to m the gradient, which is 4 over 3. So 4 over 3 by x here, which is 0, plus c. Oh, so I'm supposed to say substitute 0, 2, and m is equal to 4 over 3. All right, so you substitute the point, any one of the points. You could have used 6, 6 if you wished. But I use this one instead. So you'll end up with -2. Now 4/3 by 0 is 0, so that will just be c is -2. Therefore, the equation of the line is given by y is equal to 4 over 3x minus 2. All right? Or the second method is to substitute the same, any one of the points and the gradients into y minus y1 is equal to m by x minus x1. All right? So this would mean you're replacing y1, m, and x1. y1, again, I'm going to use the point 0, -2. Actually, let's use the point 6, 6, just to show you all that it doesn't matter, right? So it'll be y minus 6 is equal to the gradient m, which is 4/3, by x minus 6. All right, so in this method, you replace y1, x1, and m. All right, so this would be, and then you simplify. So y is equal to 4/3 times x, which is 4 over 3x, minus 4/3 times -6, which will give you -8. And then I'm moving -6 from this side to the other side, so it will become +6. And finally, the equation is y is equal to 4 over 3x minus 8 plus 6 is -2. So as you can see, both methods give you the same answer, and they're both about the same amount of working. So really, it's just your preference. All right, Fired, did you get the gradient as 4 over 3, by the way, and then the equation of the line?
Yeah.
Okay, good job. Right, so then part 3 is to determine the midpoint of the line segment. So to refresh your memory, the formula to find the midpoint, guys, is, well, midpoint using a capital M would be x1 plus x2 divided by 2 to find your x coordinates of the midpoint, and the y coordinates will be, again, the average of the y coordinates. So y1 plus y2 divided by 2. And now you just substitute your values in there. That would give me, so it's 6, 6, and 0, -2. So 6 plus 0 are the x coordinates divided by 2. And then your y coordinates are 6 and -2. Yeah, I think so. Yeah, 6 and -2. So working that out, that gives me 6 plus 0 is 6 over 2. And then the other one, 6 plus minus 2 would be 6 minus 2, which is 4 over 2. So therefore, the coordinates of the midpoint will be 6 over 2. So 6 divided by 2 is 3, and 4 divided by 2 is 2. So the midpoint, the coordinates of the midpoint is 3, 2. All right. And then the final part of the question is to determine the length of the line segment TS. So to determine the length of the line segment, you use the formula to find the length of the line. All right, so the length of the line segment TS, and you could write it like this, right, is equal to the square root of x1 minus x2 or x2 minus x1, however you want to say it, squared, plus y1 minus y2 squared. All right, so let's substitute our values in there just to recall what the coordinates were. T was 6, 6, and S, no, what was it? S is 6, 6. Oh, S is 6, 6. And T is 0, -2. All right, so let's substitute our values into the equation. We get square root of x1 minus x2, so that'll be 6 take away 0, all to be squared, plus y1, which is 6, take away y2, which is -2, all to be squared. All right, so that gives me 6 minus 0 is 6, so that would be 6 squared plus 6 minus -2 would be 6 plus 2, which is 8. So that would be 8 squared. This gives me the square root of 6 squared is 36 and 8 squared is 64. So it's the square root of 100, which is equal to 10. So the length of the line segment TS would be 10 units. And that's your full solution there, guys. All right. So this question is worth, the full thing is worth 2, 4, 6, 7 marks. Right? 7 marks. Anybody got it? Anybody got all of the answers? Nobody? Yeah? Oh, good. Good job. Wonderful. All right. And for those of you who didn't get it, did you see your errors? Evan, you saw your errors, love?
Yeah, miss.
Yeah. Fire, you saw your errors?
Yes.
Okay. Where did you make mistakes, Fire?
In the part 4D, I did mix up some the coordinates.
Oh, okay, no problem. All right, so we got to be careful there. Okay, guys, let's look at this other question. Jan 2013, a line segment GH has equation 3x plus 2y is equal to 15. Determine the gradient of GH. And then the second part of the question says another line segment JK is perpendicular to GH and passes through the point 4, 1. Determine the equation of the line JK. So guys, you see, this is like literally the same question that came before. It's identical to this one. It's the exact same question, right? Jan 2011. And look, they brought it back in Jan 2013. All they did was change the numbers, and actually barely so. All right, so to determine the gradient of GH from the equation, you have to write that equation in the form y is equal to mx plus c, right? So in other words, you have to make y the subject of the formula. Only then can you just read off the answer, or just read off what m is, the coefficient of x, which gives us the gradient of the line, right? So we have 3x plus 2y is equal to 15. So to make y the subject, I'm first going to move 3x to the other side. So that would become 2y is equal to 15, take away 3x, right? And now I need to make y, the coefficient of y equal to 1. So I'm going to divide throughout by 2. So this would be 2y divided by 2 would give me y. 15 divided by 2 is 7.5. And we could write it as decimals if we wish, or you could write it as fractions. Let's use decimals because all along we've been using fractions. So 15 divided by 2 is 7.5. And then 3 divided by 2 is 1.5, right? And this equation is in the form, y is equal to mx plus c, where m is the gradient and m in this case is -1.5, right? And I mean, if you want to like be more anal about it, you could actually write it as y is equal to negative 1.5x plus 7.5. Now it is in the identical form y is equal to mx plus c, where m is equal to negative 1.5. So the gradient is equal to negative 1.5. So I know I'm going to expect this line to be decreasing from left to right, something like that. All right, and now the second part of the question says, another line segment, JK, is perpendicular to GH and passes through the point 4, 1. Determine the equation of the line JK. So, actually, because of this part of the question, and I should have actually just done this from the beginning, because you have to determine the equation of this perpendicular line, you're going to have to use the concept of the gradient being the negative reciprocal of it, right? So it would have made sense to like write the gradient as a fraction. And I mean, it's no problem. We could do it very easily. We could just write negative 1.5 as a fraction, which is negative 3 over 2, right? So it's no big deal. And if we wrote the equation with fractions instead, it would have been y is equal to negative 3 over 2x plus 15 over 2, right? No big deal. Right. So since the line segment JK is perpendicular to GH, the gradient of JK will be the negative reciprocal of negative 3 over 2. So the first thing that you're going to do is you're going to write that down, right? You're going to say, since JK is perpendicular to GH, all right? So you see, guys, this keeps coming up. Since JK is perpendicular to GH, sorry about that, GH, its gradient would be the negative reciprocal of the gradient of GH. So the gradient would be equal to positive 2 over 3. All right. And the other piece of information they gave us is that JK, passes through the point 4, 1. So to determine the equation of the line, remember all you need is a point on the line and the gradient, which we already have. So we will substitute that point 4, 1 and the gradient m is equal to 2/3 into the equation y is equal to mx plus c, all right, where y would be the y coordinates here, so that would be 1. M is 2/3, x is 4, and then, well, we're trying to find c, right? So this would be 1 is equal to 8 over 3 plus c. So therefore, c would be equal to 1 take away 8 over 3, which gives me 1 take away 8 over 3 is negative 1 2/3, which is negative 5 over 3. So therefore, c is equal to negative 5 over 3. All right. Therefore, the equation of the line would be the equation of JK would be given by y is equal to 2/3 x minus 5 over 3. And alternatively, you could have used the second method, which is substituting that point and the gradient into y minus y1 equals m times x minus x1, replacing y1, x1 with the coordinates of the point and m with 2/3. So let's work that out. It'll be y minus y1, in this case is 1, m is the gradient, 2/3, x minus x1, which is 4. And now we simplify. So y is equal to 2/3 times x, which would be 2/3 x, minus 2/3 times minus 4 would be, sorry, 2/3 minus 4 would be 2 times 4 is 8, so that'll be 8/3. And then you're moving minus 1 to the other side, so that would be plus 1, which is the same as adding 3/3, because 1 whole is 3/3, and therefore the final answer will be y is equal to 2/3 x minus 8 plus 3 would give me minus 5/3. As you can see, it's the same answer. Does not matter which method you use, you're still gonna get the same answer. All right, guys, and as you can see, it's literally a repeat. All right, this is what they bring. What you need to know for this question, the things that you needed to know, one is that you can determine the gradient of a line from simply watching its equation. Once it is in the form y is equal to mx plus c, that means that if it is not given in the form y is equal to mx plus c, you'd have to rearrange the equation to make y the subject. All right, so you move all the terms to the other side, and then you divide by the coefficient of y throughout. That's how you would get the equation in the form y is equal to mx plus c. The next thing that you needed to know is you have to always be able to recall the different facts about the gradient, which is one, that parallel lines have the same gradient, or that perpendicular lines have negative reciprocal gradients. And that means if you know the gradient, of one line, you could determine the gradient of a line that's perpendicular to it by just flipping it and changing the sign. So in this question, the gradient was negative 3/2. So to find the gradient of a line that's perpendicular to it, you simply invert it, flip it, reciprocate, however you want to say it, however you want to recall it, and then make it change the sign. So instead of negative, it'll be positive, and it'll be 2/3 since it was originally, well, not originally, but since the gradient of the line that's perpendicular to it was 3/2. All right. And then the final thing that you had to know is that you can determine the equation of any line when you have 1 point and the gradient of that line by either substituting it into the equation y is equal to mx plus c to find what c is, or substituting it into the equation y minus y1 is equal to m by x minus x1. Both methods yield the correct answer. All right, guys. So it's the same thing over and over and over again. We're gonna do this last question, and that would be it for today. I want y'all to just do parts 1 and 2 of it, and then I'll show you how to do part 3, the equation of the perpendicular bisector. We're just gonna do this last question, and that would be it. All right, I know I have another one here. I'll probably just let you all do this one for homework. All right, so let's go ahead and do this one. The question A, which has coordinates -1 and 4, and B, which has coordinates 3, 2, are the end points of a line segment AB. Determine firstly the gradient of AB. So the gradient of AB, right, M, is equal to y2 minus y1 over x2 minus x1. All right, so guys, be careful with it. It's the difference of the y coordinates you have to use. So I'm going to use 4 take away 2, all right, divided by -1 take away 3. And that gives me 4 take away 2 is 2, -1 take away 3 is -4. So a positive divided by a negative would be a negative. So the answer will be -1/2. Right? Next thing, Part 2 says to determine the coordinates of the midpoint of AB. So, of course, you use the midpoint formula. The midpoint is capital M, right? Use a capital M because common M is usually used to represent gradient. The formula for midpoint is basically the average of the x coordinates of the endpoints, which means x1 plus x2 divided by 2 to find your x coordinates of your midpoint, and then the sum of the y coordinates, y1 plus y2 divided by 2, and that gives you your y coordinates of the midpoint. So the coordinates of the midpoint here would be, well, x1 is -1, while x2 is 3. Is it 3? Yes. And then the coordinates, so all of that divided by 2. And then y1 plus y2 is 4 plus 2. And it's one, the order doesn't matter because addition is commutative. The order matters for the gradient, but not for the midpoint. Right, so finally, the coordinates of the midpoints would be, well, -1 plus 3 is 2, and 2 divided by 2 is 1. And then 4 plus 2 is 6, and 6 divided by 2 is 3. So the coordinates of your midpoint is 1, 3. Now the last question, which is with 3 marks, wants us to find the equation of the perpendicular bisector of AB. So there are two things that you have to recall here. One is that the perpendicular bisector, right? So the perpendicular bisector of AB, perpendicular. Right? The perpendicular bisector of AB passes through the midpoint. Right? So it's a perpendicular line that passes through the midpoint of AB. In other words, it bisects AB into 2 equal halves. Right? So it would pass through the midpoint, which we just found. Right? We just found the coordinates of the midpoint as 1, 3. All right, so that's the first thing. The second thing is that the perpendicular bisector of AB is perpendicular to AB. So if that is so, it means that the gradient of AB would be the negative reciprocal of the gradient of the perpendicular bisector. So therefore, the gradient would be equal to, well, since the gradient of AB is -1/2, the gradient of the perpendicular bisector would be +2/1, which is 2. All right, and now you have these 2 points, which is what you need to consider, right? You have a point on the line and you have the gradient of the line. So we could determine the equation of the line by substituting that point and the gradient into y is equal to mx plus c, right? So substitute m is equal to 2 and the point 1, 3 into y is equal to mx plus c to find c. So that would mean 3, because 3 is y, is equal to m, which is 2, times x, which is 1, plus c. So 3 is equal to 2 plus c, which makes c equal to 3 minus 2. Therefore, c is 1. So the equation of the perpendicular bisector is given by the equation of the perpendicular bisector is given by y is equal to m2. Oops, I wrote 2m, sorry. mx plus c, which is 1. And of course, the second method, you could have substituted it into the into the equation y minus y1 is equal to m by x minus x1. All right.
Miss,
Yeah, yeah.
I did get negative 1.5. I didn't do the flip thing.
Oh, okay. So you'll have to do that, right?
Yes, miss.
Yeah, you'll have to flip it because once the gradient, whatever you get as the gradient, a line perpendicular to it would be the negative, the reciprocal of it. So you change the sign and flip it.
Yes, miss.
So then this would be y minus y1, which is 3, is equal to m, that's 2, by x, which is, oh, sorry, x doesn't change. X1 is what changes. X minus 1. So y is equal to 2 times x, which is 2x, and 2 times negative 1, which is negative 2. Move minus 3 to the other side, it becomes plus 3. So the answer is y is equal to 2x plus 1. So it's the same answer, right? Doesn't matter which method you use. Guys, it's the same thing that comes all the time, right? Look at this one that you'll do for homework. A line JK has equation 2y is equal to 5x plus 6. Determine the gradient of JK. So you have to write that in the form y is equal to mx plus c, right? And then once you do that, you could now work out the second part that says another line GH is perpendicular to JK and passes through the point 5, negative 1. So if this line GH is perpendicular to JK, it means that the gradient of that would be the negative reciprocal of the gradient of JK. And once you have the gradient, you could determine the equation of the line because you have a point on the line and you would now have the gradient. So guys, it's the same thing that comes all the time. That means that the more you practice, the better you'll get. All right. So I'm going to stop the recording now. I'm sending you all this and I'm going to, post this video. Please have a look at it if you need to go through it again and try the question, okay?